Good morning. I'm Devasena. In this lecture, we are going to discuss about diathermy and overview. This topic is present in the subject Medical Electronics. Diathermy. Diathermy is a therapeutic treatment most commonly prescribed for muscle and joint conditions. It uses a high-frequency electric current to stimulate heat generation within body tissues. The heat can help with various processes including increasing blood flow. Diathermy is electrically induced heat or the use of high-frequency electromagnetic currents as a form of physical therapy and in surgical procedures. In surgery, diathermy is used to cauterize blood vessels to prevent excessive bleeding. The technique is particularly valuable in neurosurgery and surgery of the eye. Diathermy is the controlled production of deep heating beneath the skin in the subcutaneous tissues, deep muscles and joints for therapeutic purposes. There are basically two types of diathermy devices on the market today: radio or high frequency and microwave. Although most of the newest diathermy machines are largely safe, the electric fields they generate are still inherently hazardous for the patient, operating surgeons and theatre staff. They can cause burn injury, electrocution, operating room fire, smoke inhalation and gene mutation. Types of diathermy: shortwave diathermy, long wave diathermy, microwave diathermy, ultrasound diathermy and laser diathermy. Surgical diathermy. Diathermy is the treatment process by which cutting, coagulation, etc. of tissues are obtained. It is found that when high frequency current in the range 1 to 3 MHz is applied, heating of tissue takes place. The evolving steam bubbles in the tissues at the surgical tip continuously rupture the tissue, and by that way cutting action is obtained. Surgical diathermy types representation is shown below. The two types of surgical diathermy are cutting and coagulation. They are represented here. Types of electrode tips used in diathermy is represented here. Here is a representation. In this diagram, we are having four types of electrode tips that are used for diathermy purpose. They are blade electrode tip, needle electrode tip, ball electrode tip, loop electrode tip. These electrodes tips are non-stick and they are Teflon coated. Tissue processing representation is shown below. Here is the representation. First step, knife laid on near end of stroke, then cutting edge towards the operator, two roughly in the center of the stop, knife pushed to other end of the stop from toe to heel, turned across the stop and toe brought to the center, bring knife back to the near end of the stop. Fixation, dehydration, clearing, impregnation, embedding and blocking, section cutting, routine staining. Here is a representation of specimen holder specimen block, then how the knife is used, then microscope slide. These are indicated in this picture. Fulguration, by passing sparks from a needle or ball electrode of small diameter to the tissue. The developed heat dries out the superficial tissue without affecting deep-seated tissues. This is called fulguration, in which the electrode is held near the tissue without touching it, and due to passage of the electric arc, the destruction of superficial tissue takes place. Thus, it is related to the localized surface level destruction of tissues. Fulguration process is represented here. Here is a representation. In the figure A, the electrode is applied near the tissue, and in figure B, heat is applied to the tissue. Here, there is no contact between the tissue as well as the electrode. This is indicated in the diagram. Fulguration process representation is shown below. Here, the fulguration process is being done with the help of the ball electrode. Through the ball electrode, an electric arc is applied. Here, the electrode is kept away from the tissue. There is no contact between the surface of the tissue as well as the electrode. This is represented here. Desiccation. The needle point electrodes are stuck into the tissue and kept steady while passing electric current. This creates a high local increase in heat, and drying of tissues is taking place. This is called desiccation, which produces dehydration in the tissues. Desiccation process is represented here. Here is a representation of a needle point electrode. Now, needle point electrode is applied over the tissue, and through the electric arc, the process is continuing. Types of needle electrode set is shown below. This is the desiccation process. Here is a representation of needle electrode sets that are helpful for desiccation process. Electrotomy. When the electrode is kept above the skin, an electric arc is sent. The developed heat produces a wedge-shaped narrow cutting of the tissue on the surface. By increasing the current level, deeper level cutting of the tissues takes place. Normally, continuous radiofrequency current is used for cutting. Different waveforms for different effects. Here is a representation of three processes. Vaporization. In the vaporization, the electrode is in non-contact with the tissue and it provides a waveform. Then we have desiccation or coagulation. For that, the electrode creates a contact between the tissue, and we have fulguration process. In that fulguration process, we have a non-contact between the electrode and the tissue. This is indicated in this waveform. Coagulation. When the electrode is kept near the skin, high frequency current is sent through the tissue in the form of bursts and heating it locally so that it coagulates from inside. The concurrent use of continuous RF current for cutting and a RF wave burst for coagulation is called hemostasis mode. Blending. When the electrode is kept above the skin, the separated tissues or nerves can be welded or combined together by an arc. This is called blending. Here is the representation for the blending process. If low voltage is applied means we have pure cutting process. If high voltage is applied means we have coagulation process. In between the voltages applied means we have three types of blending process that is represented here. Here is another representation. Coagulate and blend waveforms generated by machines. Here is a representation. Figure C represents the coagulate waveform produced by a spark gap generated. Figure D represents the coagulate waveform generated in a solid state diathermy machine, and figure E represents the blend waveform produced in a solid state diathermy machine. Cutting process. A combination of fine wire electrodes, high RF voltage and high cutting speeds are necessary for confinement of tissue destruction in electrosurgery. These parameters are of great value in microsurgery since localization of electrosurgical effects would be accompanied by coagulation and hemostasis. Evolving steam bubbles in the tissues at the surgical tip continuously rupture the tissue and are responsible for the cutting mechanism. Here is a representation for the cutting process. Hemostasis, a term in electrosurgery to describe a technique or result when a hemostat or forceps is clamped on a bleeding vessel and RF energy is applied to stop the bleeding. The concurrent use of continuous RF current for cutting and a RF wave burst for coagulation is called hemostasis mode. Electrosurgery representation is shown below. Here is a representation. The electrode is kept above the tissue. There is no contact between the electrode as well as the tissue. Here the sparks cause superficial epidermal carbonization. It happens over the epidermis. Below the epidermis we have dermis. This is indicated in this representation. Block diagram of electrosurgical diathermy unit is shown below. Here is a representation of a block diagram of solid state electrosurgical unit. Here we have a logic board. The logic board is connected to all the blocks. The other blocks we are having are audio tone generator, power output board, power supply, foot switch, isolator, switchboard and control panel. Monopolar diathermy is represented here. In this representation, we have a diathermy unit. A patient is lying on the plate and from the diathermy unit, the active cable is used by the surgeon. The active cable comprises of the active electrode. The active electrode is applied over the patient. Apart from that, we have dispersive cable also. This is indicated in this red picture. Thank you very much for listening this lecture. For further updates, kindly subscribe this channel. If you like this video means kindly share this video to your friends. Thank you.